How many of you have a mobile phone with them? Okay, I need no more than 50 people to take it out and go to this address so we can try if I am a good coder or not. Seems yes. So as I said before, this slide viewer tool that I'm using tonight is a ReactJS application. I built it for tonight to see with you how we can build this stuff, and I'm using here tonight. And I'm introducing in this application some concepts that I would like to try with you. So are you okay? Okay, I see that somebody's doing. So basically what you see in your device is the slides that I'm seeing in my remote. I have the power to change the slide, and you all should see the same slide that you're seeing here. So I can synchronize your device. Here I can go full screen. And what you can do with the buttons that you have in the bottom of your application is you can give me feedback, or you can tap and hold on the application to raise your hands. I see that there are like 9 people that are pushing, so be polite because there is no booking system yet in this application. Okay, I'm doing good. You see, when you give me votes with the 3 buttons, I see live what you're thinking. So keep going with the green button, please. Okay, if I don't like the red button, I can manually dismiss it, so I see only the green stuff. Okay, for the whom of you that knows about the remote, don't go there. We were here. Come on, stop using the remote.
How do you use the remote?
Johan, give me your phone. Okay, so this is a tool that we can put together in no more than a couple of hours with React. I've used React, I've used FireBase as a database, or data storage that gives me the synchronization of all those devices. And yeah, I have used images for slides. In a few minutes, we start to go through the code of this application, and we see how it is done. So there are 6-7 people that has questions right now. Who are them? Yeah, when it's time to talk, nobody. So I can dismiss you. Okay. Go ahead. So, stop it. Let's start from here, a really important concept that we see before JSX. So this stuff is not HTML. It's just a syntax that you can use. Okay, that was not your fault. It's just a syntax. Can you go move on? It's just a syntax that we can use to create this instruction. So it's just shorter. And I will use both in the application, and I will switch, and you can just follow. Let's start with a little bit of architecture about React, so to understand how we use it. So in a full application architecture, we have some services that are what you have in the backend, is the data, what you have to show, that somehow go down to a mobile device, to a computer, to whatever. Okay. In the middle, there is your application. And your application is built with data business layer, in which you take care of the URL. We are in a browser, so we have a router-based navigation. The routing, so the URL that you are asking the browser to show defines the state of the application. So what is that you want to show? Some persistency layer, so how you talk with the services and you cache data and stuff like that, and some in-memory business. How, like, to keep track of how many people are raising hands right now. By the way, you really have a question, or keep playing with it? Okay, you keep playing. Then, in the end, there is a native layer, some kind of native layer that physically build the image that you see on the device, that your users see on the device. When it comes to a browser, the native API is the DOM. iOS has its own, Java has its own, are different kind of layers. That means that are simple calls that you do to libraries. That's the native API. Okay, it's when we place a tag in a page. It's not that we are designing, writing anything on the screen. We are asking somebody to do somewhere with a definition, with a native API. In the middle, we have a machine that translates data into native API calls, and is where React takes place, is where we place our code with React. First, we have to compute, to create a set of data that contains the state of the application. I mean, that contains the instruction to define what we are going to see on our screen. At this point, we can give those informations to our render machine that takes this pure data, like the hello text that we see, okay, which slide to show, and compute the native calls with this data. So it takes the text, the hello world text, it put it into a title component, and it asks the native API to visualize this component into the device. On the other side, the device, every device that we have, that we use, can get feedback from the user. Okay, touch, keyboard, mouse. These events are again handled by the native APIs. When I touch the screen, okay, it shouldn't. Okay, thank you. When I touch the screen, an event is raised by the screen. First, it goes through the operating system, browser, blah, blah, blah. It comes into my code as a description of an event. Okay, it's not that I'm really aware of the finger touching the screen. It's a description. It's something that just bring into my state, into my application, the information that something had happened. Okay, and I can drive it in order to change what the application is in a given moment. I change the data of the application, and when the application data change in this area, the application render again, because when I click this slide, I am changing an index, an ID, and the rendering happen again in order to produce the change of the slide. Okay, that's the big picture of React, and it's important to understand that React lies only in this gray area. It doesn't talk with the services. It doesn't provide you any utility to handle URLs, routing, caching, or stuff like that. And it doesn't really gives you the ability to manipulate the native APIs. It's React that does that for you. You just provide descriptions of what to do, and you receive descriptions of what had happened in the device. Now let's go into another picture. Okay, this is the anatomy of a React component. So one single element in the React architecture that is like a room with this big thick wall that nobody can cross, but few well-defined arrows. Okay, each component in React should receive from the top, from something else, a bunch of properties. Like the hello world before receive the text, receive which string to show. This is a property that is given by something else, some other components in the hierarchy of the definition of your interface. The render machine is the render function that we've seen before. It can use these properties to release a description. So what is going outside the component is a description of some other components that will be used by React to show, to display something here. Okay, I've colored this in green because this is the main flow. It's the one direction flow, the simple stuff that you can do in React. And by the way, 85% of your components should do only this part. Okay. Let's take a look at this other part. We have actions. Actions are raised by the device, the user on the device. So because of the architecture that we've seen before, I put it from bottom up. There are descriptions of events that you take care of into your component. Do you remember the onClick that we saw before in the example. And this action should, the simplest thing, should do something, should call some libraries, should trigger an AJAX call, whatever, with something which is outside the component. Okay. In the most interesting scenario, it hit a state. What is a state? A state is a set of properties, informations, key values, a key value object, nothing more than that, that lies inside the component and then is capable to trigger a render again when it changes. So you have an API to read and write from the state from within a component, and every time you change something into the state, the render is triggered again. Every time the value of a property changes from the outside, the render is triggered again. And this mechanism is propagated down the chain of your components and subcomponents. Okay. When you release a description, eventually when you hit the bottom and all the description is given to React, React will compute a diff between your description, so the updated description that comes from the data state of the application, and what's in the page, the DOM that is already in the page. And the React will apply only the differences. It uses a shadow DOM to do that, which is part of the web components definition. So this is why it's damn fast. It doesn't change anything that is not meant to change. Okay. Then React, for defining a more complex architecture, propose a name, Flux. Okay. It's proposed like a pattern to write application is shipped with a lot of version, a lot of libraries. I did mine, so everybody can do its own version of Flux. But what is Flux? Flux is no more than an organization, a data flow pattern. It's not really a library, it's not really anything special. It's just how data flows from the data holders, so the services or the cache layer, stuff like that, that they go down to the view. The view is thanks to React, goes down to the device as an image, and events come back, and actions, because what you do here is represented as an action in your application, is capable to modify data again. The point of modification is just called store. It's just a name. Okay, it's no more than a place in your application in which you hold all the data that are needed to show your application, and in which you handle the rules to modify this data set. The rules are actions. So when I hit this button, there is an action which is called next. Okay, so the component that represents this button just call a next. It doesn't know that we are in a slide where application. It's just throw an action with a name, and it's inside the store that there is the ownership, the responsibility to understand what next mean in reference of the data that are held in the application. Okay, that's Flux. No more than that. Questions here? You can tap it and you're doing it. So, who's that? Come on. Okay, let's start to talk about FireSlide. The name comes because I use FireSlide. FireBase, thank you. So this is the big architecture. The idea was, okay, it's me talking, and that's you listening, and that's you staring at me saying nothing, and I don't really know what you're thinking. So why can't I use your device in order for you to give me feedback while I'm talking, so I know if I'm boring you, if I am doing well, blah, 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 blah. That is something that we can do with React, FireBase, and our device. And we are going to see how we do that. Let's see. So first, what you're going to see now is publicly available on GitHub. At the end, I will write down the URL. I've split the application in many branches, numbered branches, so it's like a step-by-step tutorial. The point tonight is to go through and just have a talk about the interesting point, the interesting change step by step, so you can go back at home and run it yourself, execute it in your machine, go down the code, read the comments, and stuff like that. I really please you to interrupt me, ask me stuff, discuss when you see bugs, mistakes, please talk. Okay? Okay. First, this is an application is built with JavaScript, CommonJS. I use a Webpack to put them together and a Gulp task chain to just architect all the processes. There is a little Node.js server that serves the application. This is not the objective of tonight, but just for you to know what is going on in this console is that the process that put all the files together and serve to the browser a single JavaScript file that execute the application. Let's open it here. So, how we seen my application, how we see is a simple, is made with an entry point. There is a loader that I use because this is not an isomorphic application, so you can see a flickering if there is not a curtain, so we put the curtain, and there is some JavaScript involved. It's the FireBase library, React library, and the bundle is injected automatically by the process itself. There is also a CSS layer, which is coded in less, which is injected into the HTML by the process again. So let's start by this simple application, which is close to an hello world. And it is an hello world, exactly as we've seen before. There is a module, a component that put a string into a title, and an application entry point which is capable to require this component and to render it into the page. Beside that, there is the little piece of DOM that just take off the curtain. This is the basic of the application. Let's put our first slide on the screen. So what we want to do is to show slides. It's a slideware application, so the first purpose is to show an image, full screen, stuff like that. The image is just an image. I use JavaScript. CSS to extend the image's background of a div. So what I created is another component named slide that use a div with a given class name. This is the API is not class. In React is a class name, as it reflects the DOM API's name for the class. So my application now is requiring this slide. So I have in this file the application entry point. It doesn't produce the hello world. It just requires the slide, and it releases the slide. So my application is just a slide, and the slide itself is no more than a div. Let's go inspect this element. Is no more than a div with a class. Thanks to CSS, there is a background image. Okay. What's next? Of course, I can't just show one single static image. I need to change this image. So my slide component holds the responsibility of painting this big image. Okay, and we solve the responsibility with a class name. But after that, the slide component needs to produce whatever image I feed into. Okay, it's not just a static one. So next step is to add a property to this component. To use the properties. Let's see. There we go. The next step is that the slide should accept a property in which I define which image to show, and I switched it back to JSX. So my application entry point with release as description a slide with a specific image which I can change at will. Okay, if I go to image 8, there we go, image 8. So I feed into what to do, and my slide grows in complexity because I define a style object with all the responsibility for defining which background image to use. That's simple. I just concatenate the given property, and I give the style property into the div, which is a native component of React. Okay, we added parameters to our component. Then we need, of course, to remove what I did. So far we got a quite interesting slide component that is capable to show different images. What we need is a mechanism to go forward in the presentation, and it's a simple click. So I want my slide to be capable of receiving this click in order to change which slide to show, to change the property of the image. Let's see how the code change. Oh, let's see it work before. I click and I change, I click and I change. This is for an old presentation that we did here. Let's start from the application. Now I have an array of slides, just images, URLs, and I use the state in this component. Do you remember the state, the little data holder that is part of a component and that can change inside the component? Well, I'm defining here a state which contains only one single property, is the index of which slide to show in a given moment. So then my render method is capable to use the slide component, but instead of giving a string of which image to show, it will fetch the image from this array using the index which is stored in the state. So whenever this number change, the render is triggered again, and you have the final result that changed before your eyes. Another part is that I handle an on-click event on the slide. So the slide is capable to emit something, to call me back when something happened, and I handle this event with a method of my class. In this method, I use the state API to make the index to change. So anytime you click it, I handle the click, and I change the state. I just increment the state. It's important in React to use this API, this setState API, because the state itself it should be an immutable. So you should never play directly with the state in write mode. That's for React, to trigger all its events. So the big job had been done in the application layer, and our slide is just no more complicated. We only added the on-click event that just bubble up the on-click property that a slide receive. I switch back to JavaScript here to make this more evident. The on-click is part of the native React native component that represent a div. It is not something that I did, it's something that is shipped with React, and I bubble up the on-click to the application. The outcome is that I click and I just change the state, and when I change the state, everything is rendered again. What is rendered again actually is not that the div is taken away and a new div with the new property is injected into the DOM. It's only the attribute, the src attribute of the style attribute in this case that change. So that's also really fast. Is it okay? Okay. Proceeding toward an application, we can't really handle a big complexity into the application entry point. We would like to layer down the complexity and try to give one single responsibility to each component in our application. So in this step, I've tried to make my application a little bit more easier. So instead of dealing directly with the slide in my application entry, I decided to deal with a slide deck. Okay, a slide deck holds the responsibility to pick up the correct image given the correct index. So in my application, I don't directly deal with the array, the list of images. I just give to this deck the slides that the deck has to show, what is the current slide fetching from the state, and the deck is capable to give me an on-click callback so I can change my state. The state is still at the application level. So let's see. In this application level, I have the state. Then I have a slide deck component that receives some properties, and I can also use this prop types property of a class that is a definition of which type is expected for which property. It's basically a validation, a set of validation rules that are applied to the properties that are received from a component. It's something that is working only in development mode. So you have to set the development environment in your Node compiler. So this is used while you are developing the application and you receive warnings in the console, and it's stripped away in a production release. So you don't have to bother with this stuff in production. You have a bunch of types to say that this slide is expected to be an array and is expected to be required. So if I try to use the deck without giving as an array of slides, it will trigger an exception to me, a warning in this case. This is really useful. At Citrix, we actually enforce ourselves to use to define the prop types for each component, because it's a really good and simple method to document the properties that a component receives. So whenever I want to use a component that a teammate made, I just go in here and I'll take a look at the prop types to have an idea of what the component should do. Okay, inside this slide deck, look, the only responsibility that the slide deck has so far is to compute which image to give down the slide based on the index property. There is no state here. It's a component that implements only the green part of the component architecture that we've seen before. It receives properties and it releases a description. The slide itself does exactly this. It receives properties and it releases a description. It does not deal with the state. So far, the slide bubble up and on click. The slide deck here again bubble up and on click. So they don't really handle the user interaction. They just bubble it up. Okay, so at this stage we have an application that is holding the state, so what is changing during the user interaction, so which slide to show. And we have a set of sub-components that receive properties and forward properties down the chain. They are called pure rendering components. They don't hold state. Okay? They are pure rendering machine that receive properties and they release descriptions. When the property change, the description updates. And this is the perfect flow in React. Too bad we have two elements that bubble up and on click. That's really awful, is it? I mean, I would never like to see this code. Then is when the store, Flux with a store, come into the picture. Let's see this one. Now it's time to simplify the application, because we have a slide deck and a slide that does a really good job. They just take properties and render, and we have this big complexity in the application that holds the list of slides, hold the state of which one slide, and take back the interactivity from the slide deck, the on-click, and does a lot of job, little too much. So we can make it simpler actually. We can delegate the state. We can delegate the knowledge of what is about to be shown, what is the data that we need to release descriptions to an external element which is not part of our component entry point. And I do that in this little row. I'm going to explain it quite quickly. So I still use a slide deck in which I give the slides, in which I give the current slide. Okay, I give to the slide deck, I say, okay, here you go with the slides that you have to show, and here you go with which one you have to show. Do your job. These elements are held into the state of this component, but the state of this component is held externally, had been delegated to a store. Let's see what a store is. A store is an object in which I just moved the initial state of the component. I just really copy, cut, and paste the initial state, so the slides and the current index, the initial current index, into another object, which is just not my component. This is the first part. The second part, the store declares a list of actions, a manifesto of actions. Actions are just names. Okay, something that you can do with this set of information. What you can do is connect. What does it mean is the store that knows what it means going next. In this case, go next, it means to increment the current state, check if you are going over, if you are Stack Overflowing the slide, and if you are refusing to go over. Eventually, if you are if you can go to the next slide, you can set the state, set the new state. So I override the current value, which is above, with the new one. Okay, the store hold the informations, declare the list of actions that can be done, that can be triggered over these informations, and knows what those actions means, what those action does, and the implementation does the change in the state. Okay, this is a library that implements the store in Fluxo, in React. Its name is Fluxo, and this is the API that this library offers to tie a store with a component. It's just mixing in the state into a component. This app.jsx component, now it becomes something really strange. It's something hybrid because it doesn't receive properties. It doesn't explicitly have a state, but it holds a state, which is given by a controller, by a component. Okay. In React, they call this component a controller view. It's just a definition of the initial, the first entry point of your application that is connected with a store. Okay. Questions here? Mm-hmm.
Next, but you didn't have any actual function or anything that was next, like on the next. And how would you just get?
Because when you this is a naming convention that when the next action is triggered, the on next method is run inside the store.
It will look for something called on next.
Yeah. Yeah, it's just a naming. There are really more than 35 implementation of a store and the Flux mechanism in NPM. It's not that one is better than the others. They solve different purposes. A lot of are made over promises that allow you to really synchronize a really big application. This is an implementation that is meant to be extremely lightweight, extremely fast, and it's just a relay on a pub sub mechanism that is done in memory. You just pick up the solution that is good for your problem. There is no best library for doing this. As I said before, Flux is only a data flow pattern, a data flow organization. Just no more than that. But we are missing the element that actually trigger the next, that say, go next. Okay, who's the one that knows about this? To me, in my understanding of this application, is a responsibility of the slide deck. So it's not really the slide that knows about going next, it's the slide deck. So the slide still hold the user interaction, the on click, and it bubble up to the deck. And the deck is responsible to talk with the store to say, store, please, go on, move next. So in the store, the on click now is implemented here, and I just trigger go next to the store. Let's see if it works. So I can go next until the end, in which I start to receive the warnings that there are no more slides. So now I have a really nice and tidy architecture in which I have this state. The state knows which slides and which one. The state is given to an entry point. The entry point forward properties to the deck forward properties to the slide receive the user interaction. It gives the user interaction back to the deck, and the deck is capable of politely asking the store to perform an action to go next. Okay, this is a complete architecture that we have in place. From this point over, we just add features to our application. So I will go quite quick. I think I will stop when it's 8 so we can discuss a little more, and you can continue at home because now the code start to be a little more change step by step. Let's see. A nice feature when it comes to an application like that is being able to preload the images. So when then I change from the first to the second, you just see the image, you don't see the image loading. Okay. And this is again a component that I can drop into my application. Let's see how it goes. From this moment on, I will always start to think about the new feature as what do I need in the state to drive this feature, to represent this feature. In this case, a preload, what do I need is I need only to know how many pictures I've already cached. I already know how many pictures do I have from the slides array. So when the number of the cached pictures, images, match the numbers of slides, it means that I'm done. Okay, so I add these informations. I push the slides outside my store because in a real scenario the slides maybe are provided by a cloud service. I will upload the slides somewhere in Dropbox, and in a JSON file I will tell my application what to show. Okay. Now we go to FireBase.io and we see only today's presentation. I plan to change this in order for you to be able to run your presentation on the same service. So then I moved these informations into the HTML. So you have into the HTML of the page, I set the list of the images. In the application entry point, I just fake an asynchronous loading of those images. So I just fake an AJAX load, and in a timeout, so it's asynchronous, I trigger a new action on the store. I tell the store, I have new slides. Here you go. That's those are the slides. This is just the list, the array. Okay. So the store starts to be a little more complicated. There are no slides initially. I can implement the new slide, the on new slide, the on new slide action to receive the slides and change the state. It also resets stuff. So when it receives new slides, it basically means that a new presentation is about to start. So I reset the cached information and the current. So anytime I reload, it will start from scratch. Okay, and then it starts just a loop asking for some library that I may have found online on npm somewhere to cache an image. I give the URL and it just caches the image. Caching again is asynchronous because it involves download. So when a single image got cached, I just ask to trigger another action. This is actually important. I have the implementation of an action in the store that triggers another action. Why is that? This is to me one of the most important parts of the architecture of the store. It's because you have simple, straight entry points for events that should change the state. Whatever event, whatever needs to change the state is driven through an action, even if it's an internal stuff. Here, I could have straight changed the state, incrementing the cached, okay? But then I would have introduced an inner dependency, an implicit dependency on a store change. By driving every kind of change in the state through an action that goes through a manifesto, which is a documentation in my code, everything got simpler, especially when you bring back this code in a month, or when a colleague brings back the code, because you have straight documentation of in the word, in the name of an action, you have the documentation of why the data should change, why the state should change. Okay, that's really, really important in an enterprise application. Okay. My application got a little bit bigger. It's still simple because it still receives all the data, but now has more than one single responsibility. It needs to show the slide deck if it's time to show the slide deck, or it needs to show a preload if you are just caching the images. How I do that? I do that with two simple decisions, and I create the information that I need to take the decision within the render by manipulating the state, by reading the state. So I create a progressive, what's the name? I create a bunch of information here in which the second depends on the one and so forth. So I understand if data is ready when I have slides. If I don't have slides, it's because I'm still waiting for slides to come. Is it preloading? Well, it's preloading when the data is ready and I don't have cached everything. Is it showtime? Is it showtime when data is ready and I'm not preloading? Okay, that's quite simple. These operations in JavaScript are extremely fast, and I can totally afford to repeat those information anytime the render method runs. There is totally no meaning performance-wise to cache those information. When I came from two-way bindings and the observable pattern, I needed to really focus on performance optimization since the beginning of my development. And I had to try to add whatever cache level on the observables chain to reduce the amount of recomputation of observables. That was really sensible. Okay, we were dealing with mobile devices, really crap devices, so it was really sensible. In React, we don't need that because these are simple atomic and synchronous calculation on booleans or integer. They don't mean a thing about performances, and I can express my application in this extremely simple way. Okay, so I abstract the two little sub-application, loading and working with two components. Each of those are again pure rendering machines that receive properties and release descriptions. So the preload has the task to just create a little structure of nodes, of subcomponents to show how many have you cached, how many do you have to cache, to compute a progress in percentage, and to show a progress bar, which is another subcomponent. Okay, you got the picture about that. What is interesting here is that because I drive all my state through a store, I can make this store quite interesting. I can add to the store some mocking capabilities. What is the problem in this piece of application? Okay, I really like CSS animations, so I don't know if you noticed, but the green bar is going on, and the CSS here had grown a little bit complicated, and I want to test the CSS more than the JavaScript. JavaScript is straightforward to me. CSS, I'm not that good in CSSing, so I really need to test it. Well, what I can do now that I have all the data in the store and I have a pure rendering machine in React, so a bunch of components that uses this data just to produce an application, I can fake the store. I can do that with a simple API. In the entry point of the application, the real entry point, I just require the store and I mock it. This piece of code gives to the store a state that I have control over it. So I give a list of slides, and I tell him that I've already cached 2 slides, and I tell him to fake all the actions. So whatever action the code, my application is trying to trigger in the store is just faked. Let's see what happened. There you go. I am freezing my rendering to this state, which I completely control. So I can focus on the CSS with the elements and the expector and change the color and fine-tuning the height and stuff like that, work with the designer. Okay, that's part of my workflow. Freezing the application rendering process on a given state, completely under my control, and focus on the graphic details. Absolutely, yes. This is necessary. This is the bottom line of using testing, because the data that I am giving in to this mock API, which is just stopping the action from triggering, is really simple. This is a fixture. This is a perfect definition of a fixture. We'll see later on. I will save this in a file and I will feed this to my unit tests. So I can completely control what is going to be rendered and I can test it. And I can do that with a unit test setup based on Karma, Mocha and stuff, or a WebDriver that runs Selenium, or even manual testing, because I can ask a tester to please find bugs here. And he will go with scale and measure that the line is exactly 2 pixel height. Okay, that's that, guys, is quite important. Do I explain this good for you? It's okay? It's too simple stuff. Do I go more quick? Let's speed up. Let's talk about routing. So again, here we've seen when we did the test, I had one application showing the presentation, my application controlling the presentation, and your application giving me feedback and synchronizing with. So this code holds 3 applications, really not 1. And I can, the simple way to define which application to show is to use a route, a URL. So if I want the remote, I can move my slides. Okay, it's sensible to the click. And if I don't want the remote, I can't do anything when I click. This is the showing, and the remote is the controlling. So the application is still the same as before, so there is no fancy stuff. I just downloaded an npm package for having a router that is capable of listening to the routes. It's using the hashtag because it didn't implement any active push on this server. Lazy. And I just define some routes that listen to the URL. Again, the routes does nothing but changing something in the store. Okay, so what a route is for my application is no more than another property in the store. Okay, what is the application that I have to show? What is the mode that I have to show? Then I've abstracted this mode into subcomponents, into different components, a remote and a show component. Okay, that it will become the entry points of two really different applications that so far are really simple. They just differ for a click. And my application had become a responsibility of showing the preload or showing the main UI. Okay, this is the entry point. Am I preloading or am I showing the main UI? And the main UI has the responsibility of showing which application based on the information which is stored in the store. Again, it's another pure render component. It just receives the mode. It does a case to return different components, and it forwards all the information that each sub application needs. Okay, if we go to see show and remote, the show just shows the slide, and the remote it just handles the click. So far it's really simple, the difference. But you got that. We added a router that in a lot of scenarios seems to be that really complicated component to add that handles only God knows which kind of data. In this scenario, with the store as an entry point of the data of our application, it's just a matter of triggering an action. The action knows what to do. The router doesn't care really. Okay, let's add the synchronization. So you see that I was clicking, here was changing, in your devices it was changing, so there was some kind of synchronization. I've already told you I use FireBase for doing that. Let's take a look at the database structure. What I really need to sync is which is the current slide, which is the index of the current slide, no more than that. That's what I need to think about my application so far, to just change the slide. Then I have some more stuff for handling the votes and the raised hands. Okay, that's it. This information is already stored in the store. I don't need, I need nothing more than that. What I need to do is to interact with the store in a read-write mode and interact with FireBase in a read-write mode. So then when FireBase updates its value, I push the value into the store, and when the store updates its value because of the remote, I push it back on FireBase. And I totally leverage on FireBase to spread the message to all the connected clients. Okay, I'm not doing anything on the server here. Well, I do that in a mixin for the store, so it's just an external file that can hook into the initialization of the store. And this is trivial, I would say. You just list. How many of you knows FireBase? Okay, FireBase is just a key value store for the others that emit events. when stuff changes. So you can subscribe to events, to data events, and you use some really simple APIs to change. Okay, it's just good. It works with a URL, so data endpoint is represented by a URL in the database. Here I am subscribing to the value event when the value change in my slide index stuff, and I trigger an event to change the slide. Oh. I trigger an event to change the slide. I trigger an event to tell my state that I am synchronizing, that the sync is active. I just emit events to the store. I don't deal with the store. I emit events to the store always. Here, down here, I'm doing the very other way around. I listen to the store that change. So when the store change emits an event, and I am updating the current slide on FireBase. So it's just two-way syncing, but I'm syncing the store with the remote data hosting. I'm not changing anything in my application. That's also quite interesting because I could have added a quite cool application, okay, thanks to FireBase that gives me the mechanics of this. But I didn't change the application. And by adding this simple code, okay, this is just listening whether the application is, the synchronization is active or not. Now
It doesn't make sense to bundle your set states. I mean, you set state twice there, but it will trigger.
No, there is a mechanism in the store that doesn't trigger when you don't change data. So if you
but the set slides would trigger set state in the store, I guess, and then the.
Yes, but if you trigger 2 times the same data, it only the first time the action will take place.
But the first time you set value and the second time set true, that's 2 different states.
Sorry?
The store triggers that slide and the store triggers.
Here?
Wouldn't that in theory would mean that you would set the state twice?
Yes, of course.
And that, I guess that doesn't. So you would run render method twice.
Yes.
But it's no performance.
That's exactly part of React. In an early stage, you completely don't care about this stuff because you can afford to re-render many times, okay, or to trigger the re-render many times. In this scenario, I will trigger 2 times the state change, and React will do it once because the state that change in a component is delayed. So React takes care also of these errors of mine. Okay, so yes, this should be a non-optimized way to deal with code. But look how explicit it is in the code. So I gain explicitity when I put hands on, and it's a framework that takes care to make a good performance out of this. Okay, I often say that enterprise coding should be boring. Okay, so like instead of thinking to couple these 2 changes in one single action in the store to have a better performance, I can focus on make 2 boring but really explicit actions, and don't care about that. It's not that I don't care; it's that I know that it's taken care by the framework. Jörn?
If I understand correctly, you're gonna force 2 changes onto the virtual DOM. So far it will be expensive, but React only syncs with the real DOM 60 times per second.
And it's gonna change in the next stable release again.
Yes, it will do it the next tick and then the next tick. So you will have time to do a lot of these things in 16.6 milliseconds.
Yeah, but it's more in the next. I mean, it's digitalized as a FPS in 1/60, but also is at least in the next tick. So if within a component, so to speak, I really call 100 times set state, one straight after the other, all these changes are packed into one single real state update. That's not in the current version. In the current version, they tell you that you should code as it was already in place, and it will be applied since the 0.14. So then you really don't focus on optimize your code. You focus on make it explicit for the data representation. And if you do a good data representation, chances are that the application is working really well.
But with JavaScript, nothing can interrupt this execution anyway. I mean, when you do those two updates on the store, there is no way for React to jump in between them.
No, it doesn't jump between. It pushed everything later on. It pushed everything. When this will call a set state into a component, and that part, it will be shifted in the next tick.
I see, because it's a single thread of execution.
Yeah.
So there is no, we can do 1,000 of them one by one.
Yes.
React won't do anything until we're done.
Yes. That's the, screw the password. Company policies, guys. Okay, let's see this in action, especially this part. Okay, this is working. So now I'm stuck. Why is that? Oh no, I know what. I'm trying to show the 35. Okay, so now I receive from FireBase, I'm in the show mode, so I receive from FireBase the index of the slide. So look, if I take this and I change the slide here, I've got the other browser synchronized because of the way it's binded. If I go here with the remote, let's take this away and do that. I've got FireBase updated. If I put remote on the left and presentation on the right, I've got a synchronization. That's what we experienced in our devices. Jonas, Jon, stop it. Okay, so far there is only one single entry point in the database. So if you pick up the remote, you can screw with my job here. Don't do that. Okay. This part of the code is just a FireBase API that emits signals when you lose or when you gain back connection to FireBase. So another interesting stuff that I can do just with simple React stuff is I can turn down the connection, and the show application goes in loading mode, whatever. This should say you'll just lose the connection. I just didn't it. And when I set the connection back, hopefully it will go back and keep synchronizing. Okay, that's stuff that we can play with. And the bottom line is that we drive all this information through changes in the state. So now look the store. I still have the mode. I've just added this syncing information. Okay, it's a boolean, no more than that. It's driven from the FireBase stuff, but my application is just do the very same. It just increment the amount of properties that forward down the chain. Okay, so down look, the main UI forward down the sync. The main UI again forward down the syncing to the show application, the application that is responsible to show the slideshow. Let's go see how it's done. And this again receive the properties. I promise I didn't do anything bad here. Okay. Okay, and again here I am just controlling a loading component that I don't even care how I did it, just saying that it's visible if it's not syncing. So I lose the syncing, this turned to false, this guy will show up. Okay, and it's just go over the rest. It's really, really simple. The rendering part, it will be so simply declarative that it's impossible to make mistakes here. Really difficult. Really difficult, not impossible. About transitions. That really bothered me in the beginning. Let's keep 2 remotes. So now when I change something, you see that in the controller I don't have transition. Here I have transitions, a fade transition, but I can change the stuff in my store. My store now grew and says that there is a transition which is null by default that can be changed, or I can say, if I remember, no. Okay, let's don't do this here, and let's go down the show. So I just add an information to the store. The information is forwarded down to the show element. The show element will receive this property. Oh, the get default props allows us to give default values in case we don't receive a property, or in case we receive a null value for that property. So null value are defaulted here. So now we say that if you don't give me any transition, okay, it was H slide actually. I go for a fade. If I change this to a slide, let's see that stuff. Hey. It's not working.
Because you're giving it a null value from the store and null is accepted.
Is it?
Yeah. So you need to remove null from your prop types one to put it in there.
Okay, that's awkward. I promise you it works. I just don't manage to get it to work. But that's... Hmm? I would like you to show me why it's not working. Transitions are made... basically, React gives us a ready-to-use component to do transitions. Transitions in CSS are made when you attach or detach a DOM node. Okay, not only that, but basically you apply a class that does a transition, and you have to detect when the transition ends to either remove this class or change again properties. When you attach or detach a node, it gets tricky, because when you attach a node, you have to set the transition class, and when it ends, remove it. When you want to detach a node with a transition, you need to apply the transition class that defines the transition and delay the removal of the DOM node when the transition ends. Okay, that's basically the tricky part. Why is tricky? It's tricky because we shouldn't deal directly with the nodes in React. Okay, it's something that we shouldn't do. So this component mask this for us. It just add a class name and takes care to listen to the DOM events. Okay, I think it's 8. I don't go any further here because it's getting late. But I suggest you to go through the rest of the steps. There are quite interesting part, and I will add all the unit testing support for this. The URL is this one, if you want to take it out. And I will be also available for questions, and we will meet again, trying to go more in deep. This was an initial introduction to React. I hope you like it. Thank you.